On March 1, 2025, China conducted a significant test launch of a hypersonic air-to-air missile over the Inner Mongolia Autonomous Region, marking a notable advancement in its military capabilities. This missile is specifically designed to target advanced stealth bombers including the US B-21 Raider and boasts an impressive operational range exceeding 1,000 kilometers while achieving speeds of up to Mach 9. This development has profound implications for aerial warfare and the strategic balance of power in the Indo-Pacific region. Background and development. The missile's existence was officially confirmed by Chinese authorities on January 19, 2025, when it was announced that the final tests of the hypersonic air-to-air missile had been completed. This announcement was part of China's ongoing efforts to enhance its military capabilities and counter advanced aerial threats posed by adversaries, particularly the United States. Analysts believe that the missile's design and technological advancements signify a leap over previous Chinese missile capabilities such as the PL-17, which has a range of approximately 350 to 400 kilometers. The missile's development has been characterized by rigorous testing, particularly in heat resistance technologies, which are crucial for ensuring its survivability during high-speed flight. The missile was subjected to extensive heat resistance tests in specialized wind tunnels capable of simulating extreme temperatures exceeding tens of thousands of degrees Celsius. These conditions mimic the intense friction encountered at hypersonic speeds, thereby ensuring that the missile's materials and electronics can withstand the harsh environment of high-speed flight. Strategic implications. The introduction of this hypersonic air-to-air missile fundamentally alters the dynamics of aerial combat. With its remarkable speed and extended range, the missile can engage high-value targets, such as bombers and aerial refueling aircraft, before they can respond. Its ability to strike from over 1,000 kilometers away provides a tactical advantage that could redefine air superiority. Experts emphasize that the missile poses a significant threat to advanced stealth aircraft like the B-21 Raider. While the B-21 is engineered with advanced stealth capabilities to evade detection, the speed and unpredictable flight paths of hypersonic missiles could outpace current missile defense systems, complicating interception efforts and reducing the reaction time for enemy defenses. Technological race. The development of hypersonic technology has intensified the ongoing arms race between China and the United States. Both nations are heavily investing in hypersonic weapons, which are viewed as game-changers in modern warfare. As China continues to refine its hypersonic missile capabilities, the United States must innovate and adapt its military strategies to counter these emerging threats. This has led to heightened concerns regarding the effectiveness of U.S. military operations and the potential vulnerabilities of its advanced aircraft. Future considerations. As China integrates hypersonic missiles into its Air Force, considerations regarding the aircraft best suited to deploy these advanced weapons become crucial. Potential platforms for launching hypersonic missiles include 1. Chengdu J-20. As a fifth-generation stealth fighter, the J-20 combines advanced stealth technology with high-speed capabilities, making it a prime candidate for carrying hypersonic missiles. 2. Shenyang J-16. This multi-role strike fighter based on the Russian Su-30 could also serve as a viable platform for hypersonic missiles given its larger payload capacity and versatility. 3. H-6K bomber. A strategic bomber capable of carrying a wide range of munitions. The H-6K could effectively launch hypersonic missiles against critical enemy targets from considerable distances. 4. Y-20 transport aircraft. Although primarily a transport aircraft, the Y-20 could be modified for special operations to deploy hypersonic missiles flexibly and rapidly. The successful integration of hypersonic missiles into these platforms will significantly enhance China's air power capabilities and reshape the nature of aerial warfare. As adversaries re-evaluate their defense strategies in light of these rapidly evolving threats, the implications for global military balance are profound. Conclusion. China's successful test launch of a hypersonic air-to-air missile represents a transformative advancement in military technology. With unprecedented speed and range, this missile poses a serious challenge to existing aerial defense systems and could redefine the parameters of air superiority. As China continues to develop and deploy these advanced capabilities, the landscape of modern warfare is poised for significant change, necessitating urgent adaptations from adversaries, particularly the United States. The trajectory of hypersonic weapons development underscores the necessity for nations to keep pace with evolving military technologies and strategies to ensure national security in an increasingly complex geopolitical environment. 1. Technological oversight. While hypersonic missiles are often highlighted for their remarkable speed and ability to evade interception, a counterintuitive aspect is the challenge of targeting advanced stealth bombers like the B-21 Raider. The missile's effectiveness hinges not only on its speed but also on its ability to detect and engage stealth technology, which remains a significant hurdle for many air-to-air systems. 2. Cost versus effectiveness. There's a prevailing notion that hypersonic missiles will dominate future aerial engagements due to their speed and range. However, the high costs associated with developing and maintaining such advanced missile systems might lead to debates about their actual battlefield utility versus traditional missile systems, which are cheaper and more reliable. 3. Vulnerability of stealth technology. The expectation that stealth aircraft will become obsolete against hypersonic missiles overlooks the potential for continued advancements in stealth technology. As hypersonic missile capabilities grow, so too could innovations that enhance stealth features, suggesting a dynamic evolution rather than a straightforward advantage for hypersonic systems. For strategic miscalculations, the emphasis on hypersonic missile development may lead to miscalculations in military strategy. Nations might overestimate their deterrent capabilities, potentially provoking adversaries to escalate conventional arms races or invest in countermeasures that neutralize the perceived advantages of hypersonic technology. 5. Integration challenges. The narrative often simplifies the integration of hypersonic missiles into existing air forces. In reality, adapting aircraft and command systems for hypersonic operations involves significant logistical and tactical challenges that could delay their deployment and effectiveness in real combat scenarios. 6. False security. While hypersonic missiles are touted as game changers, their mere existence could lead to a false sense of security among military planners. This assumption might result in complacency regarding other evolving threats such as cyber warfare or drone technology, which could be equally, if not more, disruptive to traditional air combat paradigms. 7. Broader military implications. The focus on hypersonic air-to-air missiles may shift attention away from other crucial areas of military development such as electronic warfare and drone capabilities, which could play vital roles in future conflicts. This narrow focus might result in strategic imbalances and vulnerabilities in military readiness. 8. Geopolitical dynamics. The narrative suggests a straightforward technological arms race between the US and China. However, other nations may capitalize on these developments by enhancing their own military capabilities or forming alliances that could counterbalance the perceived threat, complicating the geopolitical landscape in unexpected ways. 9. Rethinking air superiority. The introduction of hypersonic missiles is often framed as a means to achieve air superiority. Yet it could fundamentally alter what air superiority means in practice. The need for multi-layered defense systems and integrated tactics may emerge as more critical than simply possessing faster missiles. 10. Public perception and defense spending. The hype surrounding hypersonic technology might lead to increased public support for defense spending, but it could also generate backlash if these technologies fail to deliver on their promises. The military-industrial complex may face scrutiny regarding the allocation of resources toward hypersonic programs versus other pressing defense needs. The recent test launch of a hypersonic air-to-air missile by China has generated significant attention. But several critical aspects of this development may be overlooked despite their substantial implications for global military dynamics. Below are key elements from the report that warrant deeper examination as well as an explanation of their significance. 1. Heat resistance testing. While many reports mention the missile's impressive range and speed, the extensive heat resistance testing it underwent is often glossed over. This testing utilized specialized wind tunnels capable of simulating extreme temperatures that the missile would encounter at hypersonic speeds over 1,200 degrees Celsius. The significance of this detail lies in the engineering challenges that hypersonic technology poses. The ability to withstand such high temperatures is crucial for maintaining the integrity of the missile's components, particularly its electronic systems. This indicates a high level of technological sophistication and reliability that could give China a substantial edge in missile technology. 2. Strategic shift in aerial combat. The missile is specifically designed to target advanced stealth bombers like the US B-21 Raider. This focus on engaging high-value aerial assets is significant because it reflects a strategic shift in aerial warfare. The ability to target and potentially neutralize stealth bombers before they can deliver their payload could drastically alter the operational environment for air forces. Traditionally, the advantage in air combat has been with stealth and surprise. However, with hypersonic capabilities, the dynamics of engagement could favor the side with superior missile technology, thereby shifting the balance of power in the Indo-Pacific region. 3. Technological arms race. The development of this missile highlights an ongoing technological arms race between China and the United States. The extensive investment in hypersonic technology by both countries indicates a recognition of its potential to redefine military capabilities. While the US has been working on its own hypersonic systems, the rapid advancement of China's capabilities may compel the US to accelerate its own programs or adopt new strategies to counter these emerging threats. This arms race is not merely about technological superiority but also about strategic deterrence and maintaining regional influence. 4. Integration challenges and opportunities. The report discusses potential platforms for deploying these hypersonic missiles, including the Chengdu J-20 and Shenyang J-16 fighters as well as the H-6K bomber. The integration of hypersonic missiles into existing air platforms poses both challenges and opportunities. For example, while the J-20 is designed for stealth and high-speed interception, integrating a hypersonic missile could require modifications in terms of payload capacity and avionics. This development could lead to a transformation in the roles of current aircraft, enhancing their strike capabilities and redefining Air Force structures. 5. Impact on U.S. military strategy. The implications for U.S. military operations are profound. The B-21 Raider, designed with advanced stealth capabilities, may find itself vulnerable to these hypersonic threats. The ability of Chinese missiles to engage such aircraft at ranges exceeding 1,000 kilometers means that U.S. strategic bombers may need to operate from greater distances, potentially limiting their effectiveness. This raises critical questions about U.S. military strategy in the Indo-Pacific and necessitates a reassessment of air defense systems engagement protocols and overall military posture. 6. Global military technology landscape. The advancement of hypersonic missiles by China signals a broader trend in military technology development. As few nations, including the US and Russia, are investing heavily in this domain, China's advancements could inspire other nations to pursue similar technologies. This could lead to a proliferation of hypersonic capabilities globally, complicating the security landscape and increasing the risks of miscalculation during conflicts. 7. Economic considerations of development. The report notes that hypersonic systems pose not only technological challenges but also economic ones, as they require costly infrastructure for testing and development. The investment in such technologies signifies a long-term commitment from China to enhance its military capabilities, which may strain resources and influence domestic priorities. The economic implications of sustaining a hypersonic weapons program could affect China's broader military modernization efforts and its geopolitical ambitions. 8. Re-evaluation of air superiority concepts. As hypersonic missiles become integrated into warfare, the traditional concepts of air superiority may need re-evaluation. The speed and unpredictability of these missiles reduce the reaction time for both offensive and defensive operations. This could necessitate new tactics and technologies to counter hypersonic threats, fundamentally changing how air forces prepare for and engage in combat. Conclusion. The recent test launch of the hypersonic air-to-air missile by China represents a pivotal development in military technology that carries far-reaching implications. While the missile's range, speed, and targeting capabilities are often highlighted, it is the associated challenges and opportunities, ranging from technological sophistication and strategic shifts in aerial combat to economic considerations and broader implications for global military dynamics, that are critical to understanding its significance. As nations navigate this evolving landscape, the need for adaptive strategies and innovative solutions will be paramount in maintaining strategic advantages and ensuring security in the face of rapidly advancing threats. 1. Technological advancements and capabilities. A hypersonic air-to-air missile developed by China represents a significant leap in military technology, boasting a range exceeding 1,000 kilometers and a speed of Mach 9. This advancement not only enhances China's ability to engage high-value targets like stealth bombers but also shifts the paradigm of aerial warfare. The missile's design incorporates advanced heat resistance technologies, which are crucial for maintaining operational integrity during high-speed flight. This capability challenges existing missile defense systems and necessitates a re-evaluation of air combat strategies, particularly for adversaries like the United States. 2. Strategic implications for air superiority. The development of this hypersonic missile could potentially alter the balance of power in the Indo-Pacific region. By targeting advanced stealth aircraft such as the US B-21 Raider, China is directly challenging the air superiority that the US has maintained. The missile's ability to engage targets at such extended ranges complicates the tactical landscape, enabling China to neutralize threats before they can respond effectively. This capability emphasizes the need for the US and its allies to innovate and adapt their military strategies to counter a rapidly evolving threat. 3. Impact on military doctrine and defense strategies. The introduction of hypersonic missiles necessitates a fundamental shift in military doctrine and defense strategies. Traditional missile defense systems may struggle to intercept hypersonic projectiles due to their extreme speed and unpredictable flight paths. This situation compels military planners to rethink existing air defense frameworks, incorporating new technologies and strategies to counter hypersonic threats. As hypersonic capabilities proliferate globally, nations must enhance their situational awareness and response mechanisms to defend against these sophisticated weapons. 4. The technological arms race. The development of China's hypersonic missile underscores an ongoing technological arms race between major world powers, particularly the US and China. Both nations are heavily investing in hypersonic technologies, reflecting a broader trend in military modernization. This arms race raises concerns about the potential for escalation and conflict as countries strive to maintain strategic advantages. The focus on hypersonic capabilities not only emphasizes speed and range but also highlights the complexities of modern warfare, where technological superiority can dictate the outcome of conflicts in increasingly unpredictable environments. In summary, China's hypersonic air-to-air missile represents a transformative development in military technology that could redefine air combat dynamics. Its implications for strategic balance, military doctrine, and international relations necessitate thorough analysis and proactive adaptation by adversaries. 1. The U.S. Air Force's X-51 Waverider. The X-51 Waverider was a prototype hypersonic cruise missile developed by the U.S. Air Force, designed to demonstrate the viability of sustained hypersonic flight. In 2013, the X-51 achieved a speed of Mach 5.1 during a test flight, marking a significant milestone in hypersonic technology. This program aimed to explore the potential of hypersonic systems for future military applications, particularly in terms of rapid strike capabilities and evasion of enemy defenses. 2. Russia's Kinzhal missile. The Kinzhal Dagger is a Russian air-launched hypersonic missile that has been in service since 2017. It is capable of reaching speeds of up to Mach 10 and has a range of approximately 2,000 kilometers. The Kinzhal is designed to target both ground and naval assets, and its speed and maneuverability make it difficult for existing missile defense systems to intercept. Russia has showcased the Kinzhal as part of its modernization of military capabilities, aiming to counter perceived threats from NATO and other adversaries. 3. India's BrahMos 2. The BrahMos 2 is an upcoming hypersonic cruise missile developed by India in collaboration with Russia. Expected to have a speed range of Mach 6 to Mach 7. The BrahMos 2 aims to enhance India's strategic deterrence capabilities. The missile is intended for use against naval and land targets, and its development signifies India's commitment to advancing its military technology in response to regional security dynamics, particularly concerning China and Pakistan. The BrahMos program highlights the growing focus on hypersonic systems within global military strategies. The recent test launch of China's hypersonic air-to-air missile over Inner Mongolia marks a significant milestone in military technology and strategic capabilities. As this emerging technology develops, several predictions and implications can be outlined regarding its future impact on global military dynamics, air combat strategies, and international relations. 1. Redefining aerial combat. The introduction of a hypersonic missile with a range exceeding 1,000 kilometers and a speed of Mach 9 fundamentally alters the landscape of aerial warfare. Traditional air combat strategies, which often rely on the engagement ranges of conventional weapons, will require re-evaluation. Adversaries will have to develop new tactics to counter the speed and range of hypersonic missiles, which could make previous air superiority fighters and bombers vulnerable long before they can deliver their payloads. 2. Accelerated arms race. China's advancements in hypersonic technology are likely to spur an accelerated arms race, particularly with the United States and Russia. As these nations strive to maintain their strategic advantages, we can expect increased investment in hypersonic weapons development, defense systems, and countermeasures. The U.S. may expedite its own hypersonic programs while developing enhanced radar and interception systems to counter threats posed by such fast-moving missiles. 3. Impact on stealth technology. With the advent of hypersonic missiles, stealth technology may be less effective than before. The ability of these missiles to engage advanced stealth bombers like the B-21 Raider presents a unique challenge. As a result, we could see a shift in focus toward developing next-generation stealth technologies that can withstand or evade hypersonic threats, or even the creation of new air platforms that prioritize speed and maneuverability over stealth. 4. Operational integration and tactics. China is likely to integrate hypersonic missiles into various platforms, including its J-20 stealth fighter, J-16 multi-role strike fighter, and H-6K bombers. This diversification will enable flexible tactical applications from air superiority to deep strike missions. The effective deployment of hypersonic weapons might also encourage new joint operational strategies that combine air and naval forces, improving China's ability to project power in the Indo-Pacific region. 5. Shifts in strategic doctrine. As hypersonic capabilities evolve, military doctrines in the region, particularly among U.S. allies in the Indo-Pacific, will need to adapt. Nations such as Japan and Australia may increase their defense spending and collaboration in missile defense systems to counteract the threats posed by China's hypersonic arsenal. This could lead to new military alliances or strengthen existing ones as nations collectively address the hypersonic missile threat. 6. Technological innovation and countermeasures. The rapid advancement of hypersonic technology will likely drive innovation in missile defense systems. Countries may invest in developing advanced radar systems capable of detecting and tracking hypersonic missiles, as well as new interception technologies designed to counteract their speed. The focus will be on creating layered defense strategies that can engage threats at various ranges and speeds. 7. Geopolitical tensions and military posturing. The development of hypersonic missiles could heighten geopolitical tensions, particularly in contested regions like the South China Sea and Taiwan Strait. As China showcases its military capabilities, the US and its allies may feel compelled to increase their military presence in the region, leading to potential miscalculations or escalations. The strategic posturing will require careful diplomatic efforts to mitigate conflicts while balancing deterrence. 8. Economic implications. Investing in hypersonic technology comes with high costs, including research and development, advanced manufacturing, and testing facilities. Countries engaged in this arms race may face significant economic burdens, which could divert resources from other critical areas such as public health, education, and infrastructure. This competition may create a divide between nations with advanced military capabilities and those without, leading to increased global instability. 9. Future warfare paradigms. The emergence of hypersonic weapons signals a shift toward new paradigms in warfare where speed, precision, and range become paramount. Future conflicts may increasingly rely on unmanned systems, artificial intelligence, and autonomous decision-making processes to enhance combat effectiveness and minimize human risk. As military technologies converge, the nature of warfare could become more complex and unpredictable. Conclusion. The successful test launch of China's hypersonic air-to-air missile indicates a transformative shift in military capabilities that will have lasting implications for global security dynamics. As nations adapt to these advancements, the future landscape of warfare will be shaped by technological innovation, strategic realignments, and the ongoing quest for military superiority. The pursuit of hypersonic capabilities will not only redefine air combat but could also reshape international relations, necessitating new frameworks for cooperation and conflict management in an increasingly contested world.